Okay, welcome back from the lunch break. I hope you had a chance to connect and talk to your peers and other people from Cisco during the break. We're going to move further into the lovely world of data modeling and Yang modeling. We heard from Telia before how they kind of partition and built their service models and built their automation system. And now we're going to hear from and learn from Bartosz a little bit more about the practical work of actually using Yang for data modeling and some tips and tricks along that journey. So welcome on stage, Bartosz.
Hello, everyone. It's great to see you there in such a beautiful place and magnificent setup that we have here. My name is Bartosz Luraniec. I'm a software consulting engineer at Cisco Krakow in Poland. I'm busy with the network automation topics for already like 6 years, especially around the Python development, around the netconf, restconf protocols, Yang data modeling, and also with the NSO services development. I know lots of faces sitting here from the Cisco Live sessions that I had the privilege to deliver for already a couple of years across Europe, United States, and even the Australia. Last year, we had also a great workshop here with the real-time services automation, including the model-driven telemetry and the NSO. We had to even run twice this workshop, after all, in the online version. So I wanted to thank you all for your interest in this workshop. But this time, we are going to discuss more about the Yang data modeling, and specifically about the Yang data modeling of the NSO service. So I'm going to cover in today's session the key features, key messages that I wanted to actually pinpoint towards the Yang data modeling of the NSO service based on my 6 years of the development of NSO services under the CX professional services. Here, it's not like it's specified that it's an introductory session, advanced, and something in the middle. So I'm going to touch upon every aspect from the Yang data modeling. I wouldn't be really describing anything towards the basic data structures, but there will be some basic stuff, there will be some advanced stuff, so I hope you will find something for yourself. And if you at least ensure that you rock at Yang data modeling, I will be definitely glad. From the agenda perspective, we are going to recap some Yang basics, as I said. Then we move towards the path navigation and the constraints. We'll talk a little bit more about the specific features around the leaves, specific features around the containers, lists, NSO actions, and we'll wrap up with the triple M rule that I'm trying to follow always in my developments. Here, obviously, we are just having a 1 hour, so I'm not going to touch each and every option that we have in the Yang data modeling. We have tons of those in the learning labs and the developer.cisco.com/NSO, but I will as well come back to that by the end of this presentation. All right, so Yang recap. We need to start at least saying once in this presentation that Yang stands for the yet another next generation. And we are using this mostly towards the modeling of the configurational, operational data, towards the notifications, all of the RPCs, for our network automation purposes. This is widely known throughout the netconf and restconf protocols, how we are actually using this in order to configure our devices or to gather some operational statistics from there. But we are not really going to discuss about that in today's session. We want to focus more on the Yang data modeling for the Cisco NSO service. So, well, I would say that if I would have to introduce our today's session, I would say that is a Cisco NSO FAT Young. Maybe that should be a good title actually for this one. So in the NSO, we have device data models where we are actually able to describe each and every part of our configuration of the networking device, such as interface, VLAN, device ACL tunnels, OSPFs, and the whole large variety. I'm not a network engineer, so you probably know better what you are configuring in your, on your devices. But that's not something really extraordinary if we are thinking about that. It's just following the main principle that we have an NSO. We have this software-defined networking paradigm that we can connect from the single point towards many devices in our network and configure them. Our main concern here is the service data modeling, because we are working on the network services orchestrator to abstract our devices configuration towards the services. So we are creating the abstraction on top of the devices configuration to think now about service configuration. So I don't really care if I'm setting up the L3 VPN on the device A, and then on the device B, C, D, and etc. I'm thinking about the service that will span from the endpoint A to endpoint B across multiple devices. That's my focus here. Same for the other services that we can see, like multi-protocol BGP, VRF, network ACLs, and tons of the use cases that you are following on your daily basis. But NSO is quite powerful, because it's not only the device modeling, the service modeling, but also NSO inside maintains the configuration models itself. So it means that all of the settings, all of the parameters that we want to include in the NSO are as well modeled in Young. So in this sense, if we are thinking about that, we can say Young is everywhere. So if I'll get back to my NSO FAT Young, I would say actually that NSO and Young are part of the same band, and they are just playing together. There is no something like an NSO FAT Young. There is the same importance because Young is everywhere in NSO. So we said that Young models everything what is in the NSO. So we can think about that as a huge XML document. If we have the configuration database in the heart of the NSO, and we have all of these device models, service models, NSO-specific configurations, then it's a huge XML template. And how we are going to interact with this entire database in order to, for example, refer for some configuration while configuring and developing the services. We are going to use the XPath language. That's all the XPath notation will allow us to traverse through the elements that we have in the configuration database. And I'm going now to cover a little bit of those topics. There are some features that I hope you'll find useful while checking that. I will actually refer back before going into that topic to what Jan was saying in the yesterday's session, why we moved towards the Young data modeling and all of this XPath notation. And what is, in short, the XPath notation? Because very often people are really confused when I'm starting to refer to the RFC of the XPath. Now, if someone has troubles with sleeping, go ahead for the XPath RFC. Good luck. It's really tough to read and get something meaningful from that. So I hope this session will actually allow you for that. But getting back to Jan's words, is actually we need to have this structured way in order to work with data in an automated manner. Because XPath, I'm always trying to compare towards unboxing the gifts on the Christmas, for example, or your birthday. So you have a big, in the NSO sense, for example, you have a big box with the name devices that you are opening, and then you are putting from that smaller box called device, and then the smaller box called the interface, and you are going deeper and deeper inside of that, opening those boxes, where finally you are taking your gift, story of value. That's the way how the XPath in general works for the kind of the first crash and the general understanding that I'm always trying to express. But if you compare this, for example, with the normal configuration being rendered as from the spreadsheets, from the macros, then it's like a printed out paper. So in this case, if you want to work with this value, it's really tough to work. Because with boxes, you can open a box, hide something else, then remove some boxes. That's easy. But with the printed paper, well, you can use some kind of scissors as a regular expressions to get some value. But if you want to change something, it's really tough and tricky. That's why we need to have this modeling sense in our networking world. How we are accessing the YANG in the NSO? Well, most of you probably already access some of the configuration by specifying the show run command on the device and then pipe display XPath. And we are beautifully getting the XPath for the given resource in the configuration database. That might be the show run of the device, show run of the service, something NSO internally, up to you what you want to actually get. And in our YANG data models, we are then specifying the path keyword. I feel like in the weather forecast. Specifying the path keyword where we are trying to traverse from the leaf that we are from the moment that we are in the YANG data model. It might be leaf, contain a leaf list, whatever you have there, towards any other structure that you want to reference to. That's a normal keyword that we are always using in order to achieve that, to reference to some node that exists in your configuration database. From the YANG 1.0, we have as well the keyword current that actually gives you the current node that you are in. So you can easily then refer for something else that exists inside of your model following the path notation. We have two types of roaming around the model. So we have the absolute paths that we are specifying from the root nodes as in the Unix systems. And we have the relative path, what we are specifying, for example, by 2 dots to go outside of the structure 1 time, 2 times, etc. So that's a normal way of how we are mostly dealing with that kind of stuff in the Unix systems. When statement, it allows us to expose the node under the given condition. Very often used in the YANG data modeling of the service. In this example, typical one. So we have the device as a reference to our model, as a leaf ref to the device's device name in the YANG data model. And for example, we have some certain parameters that need to depend on what is the device that we are configuring. In this case, when the device that we are currently configuring, platform name is iOS, we are going to show off the option for fulfilling all of the parameters that are under container iOS. Just a simple example, but most of your parameters that you might have like a vendor specific, you'll have with this included when statement to just specify that show me this in the CLI when this condition is evaluated to true. Then we have a must. Things are getting a bit serious here because it's not only that we are showing the structure only on the given condition, but here in this case, we are restricting and ensuring that this must statement has to be fulfilled for the given node. Otherwise, we can throw the error message. In this case, we have the leaf device. We might introduce some devices here that are in the device model in the NSO and enforce that our device name have to start from the PE. Starts with function and XPath. Very useful. If you have some prefix in your names, you can, for example, by that, just remove all of the other devices and put the constraint that only PE device can be selected for the operator. Then in the CLI, that person configuring this service will see that if there is something else than the PE starting point, it will see the only PE devices can be selected message. Deref, yeah, always lots of concerns regarding that. In Yang, there are tons of different ways how we can achieve the same result. So if it's not that I'm here showing you one option here, and you are doing something in a different way, and we'll be arguing that you are doing this wrong and I'm doing this right. That's entirely up to you, as the result is correct to model this in a different way. There mostly, in a lot of examples, there is not a single way to achieve one thing. And in this case, for example, we have the option that Yang 1.1 brought to us with the deref, and we have an option to specify the received elements from the list by the option with the current. So deref actually made things easier for us, because we can just refer to the first element ordered in this node by the deref in order to get the entire single node from this node set to work further with that. In this case, I mean, if you prefer to do that, you can do that, but that's kind of error-prone approach that you can follow to specify from this list by the name, the name of the IP address, starting from the current position and going towards the port. That's the same result, but that's a more, I would say, nasty approach and more error-prone. If you use that deref, you are getting this single node instance that you are looking for, but in an easier manner. I think it can be compared in the Python loop. If we'll do, for example, for devices device, and then in this loop, you are getting this specific device from the list. So kind of similar way the deref works, that you don't have to refer towards the entire absolute path, just providing this IP, but you can just access the single instance of your values in the list. Contains, very often also used as a XPath function, where we are by passing as a first argument our leaf value, and in the second argument we are passing what it has to contain. So in this example we have the leaf port and the container encapsulation. So we want to activate only this encapsulation container when our port will include the dot. Sometimes customers want to include actually this not as a separate parameter, but for example, port might be like a 0/1.100. By the dot, we understand the VLAN. So that's actually the contains that we are using. Starts with, again, something similar to contains. We may say that we want to show off the option for choosing the QS classifier when the type of our network will start with mobile. So we have like a test ISP network, mobile 4G, mobile 5G, and we decide that we are only able to set the classifier if we are starting our network name from the mobile. Just an example, but you just have to think about that as about the strings. But we have tons of those. I'm not gonna to cover each and every of those. You can find it easy and play with that. And talking about playing with that is actually regarding talking about the DevTools. I've seen lots of times people writing their XPath expressions directly in the Yang data models. then they are just jumping to make clean all, then they are failing, then they are changing something, make clean all, they are failing again. So my strong recommendation is if you are developing a specific XPath expression, go to your DevTools in the NSO, go to the config mode, specify XPath eval, and put in this quotation your XPath expression in order to evaluate this. If that will be properly evaluated, you will see down below what are the results here. In this case, we are checking if the device contain name A or I. Very simple one. And I wanted to show on a couple of examples because I think we actually never done this really. How in other way you can verify all of your XPath expressions and what are the other non-that widely used XPath expressions that you can use. Normalizing the space. If you are getting a string value from your leaf, you can, and you have some trailing space days, you can normalize it by using this function. Translate. That might be something interesting. Very often we have like an underscore in our string, and we want to change it for something else, like for a dash in this case. We can do that by passing this leave value string, and then we are saying what we are replacing to what. Compare. We can compare two strings in the XPath. If it will equal 0, it means that we are good. I mean, that this matches. If not, if there will be some 1, 2, it will show what is the diff in terms of the characters. String length, self-explanatory, in this case 4, for the string test. Substring, it just shows us that we are getting the leave value, and we can cut the substring from this entire big string that we are providing. In this case, the first parameter, I mean here in the second parameter, 2, is saying to us where should we start cutting and how long should be this substring that we'll get from there. That might be as well useful if we want to evaluate something that is in between. Some substring before, substring after. I would compare that a little bit with the split in Python, but it works on the first one. So if we have our string and then the character, we are just splitting what is before that, what is after that, depends on the function that we have here. That might be also useful in evaluation if we have some composite name and we want to check just first part or the second part of the string. XPath eval rematch for some crazy guys that want to have really granular result. We can have the rematch regular expression based on the provided string here, and here based on the regular expressions that is coming from the XPath. Concat, something opposite to the to substringing. We are concatenating two given leaves together. So for example, we may have some switch that will name depending on the area where it is. And then we'll then concatenate those two namings, and we can verify it further in the NSO if that's something meaningful for us or not. Some node set examples. We can count number of nodes in the node set. In this case, for example, I had 3 devices, so we have that number. We can get the last element from the list. In this case, well, I'm just retrieving the last device from the devices, but maybe you have to analyze your ACL entries. You want to get your last ACL entry and do something with that, check that in the YANG. You can also use the position, so if you know that something should be on the second position, third position, on any other, you might use that as well. And the name just to print out the beautiful keypath notation here. Numeric examples, floor, ceiling, self-explanatory probably. I don't have to elaborate much on that. diff and the multiplication, just for you to see, because I know that people are very often catching by the eyes. So when you will once see that that kind of function exists, maybe next time when you'll be developing your data model, you will actually use what is here. And the Boolean examples, for sure, most of you already using this on a daily basis in the development. When we are revealing our when statement, for example, to the Boolean, if that expression in the XPath is true, to show something or hide something. Sometimes we are just swapping this by using the not. So we are specifying the XPath expression that specifically saying that we'll be matching that what we are not looking for. And then we just add the not before that, and we'll have what we are looking for. Okay, so now is the time to talk a bit more about the specific leaf examples, flags that we are using on all the structures. These are not exclusively specified for the leaves. Very often, sometimes we have the leaves and the leaf list also for these features that we'll be describing right now. But it's always hard, to aggregate everything in a single place if you want to discuss all of those flags and options. That one you know for sure already if you've done anything in the NSO. Even the basic test service usually has the leaf ref towards the existing devices. But I wanted to touch on something important here. In this example, we are trying to refer towards existing VRFs on the iOS XR device. As you can see, we have a VRF name leaf with the leaf ref that is going towards the given device VRF, iOS XR, VRF list names. So normal leaf ref enforces for us the data validation. It means that if we have VRF1 and VRF2, as you can see in the CLI, then we can only input that. We can only pick one from those two. But if we want to, for example, create a new VRF, we have that kind of logic in our package that if the VRF doesn't exist, allow me to create a new one and then, for example, attach towards the L3 VPN. I'm not able to do that because the leaf ref strictly enforcing me to use the ones that are already existing. But if I want to actually skip that kind of enforcement, then I can use the option tailf non-strict leaf ref, with specifying here still the path towards the existing VRFs. Nothing changed here in terms of the path, but the difference is that when you go now towards your CLI and you specify the VRF in this example that doesn't exist, you'll be able to go through that. And at this stage, you can simply go into your Python code and handle the logic based on what you'll be inserting further. Just that kind of example, that if you don't want to have this enforced validation, but still you want to have your hands ready, you can use the non-strict leaf ref. Default ref, that is something that is similar to the default keywords in the Yang. Very often we know the default keywords like for the MTU size. So we have default MTU size, very often 1,500. And default ref similarly works to the normal default statement, but that's the default plus leaf ref. That's how I would describe this. So it creates a default reference to the value that is already inserted into your model. It's not the default towards the value, it's the default towards the structure that exists in our data model. In this case, for example, we have a BVR interface that we can specify from 1 to 4094. And by default, by the network engineer, for example, we are obliged to rewrite this value as an encapsulation.1q tag. I can't confirm. I mean, I'm not a network engineer, so I'm just saying what we had in our L3VPN models. And then the default ref flag will actually always rewrite what is inserted in the BVI first. If we want to overwrite that value, we can obviously go. But if we will not touch this at all, this parameter, that will be by default rewritten from the BVI tag. So that's something nice. I mean, because that's a trade-off between the default and the leaf ref here, that we are just referencing towards the existing value inserted in the model. And now it's something that I was actually talking about, the MTU size, that we are very often specifying this as a default 1,500. And one time I had the situation with my network engineer that was actually aware of NSO a little bit. So he obviously gave us the entire requirements with the CLIs and what should be the optional parameter, mandatory parameter, etc. We specified in the young data model the MTU size. As you can see, that the default is 1,500, but you can still override this default value towards whatever the operator wants. And we started deploying the testing services in the lab. And this network engineer has come actually towards our lab and start issuing the show run of the existing services. And came back to actually shouting at us, like, why we haven't configured the MTU size, because he specified that it has to be there. And the truth is that, well, we configured that, but if the value is default, if you use the show run service, you will not see at all this parameter. So this engineer was really thinking that we haven't configured that at all. And that's why it's a good practice to actually, if you have a default value, use the flag tailf CLI show with default, because that will then not confuse anyone if we will be analyzing the show run of this service. Then that will appear, and that's completely fine. If we will not specify that, obviously this MTU size would appear in the service, but only if we will override this default value to something else. Then it will be respected as a new value. Just a small thing, but makes people happy. CLI expose key name. Again, a small thing, but makes a huge difference. We had one situation that we are configuring the young data models per the device name and the VRF name. That was a kind of like a composite key that we are using in the model. And the funny part here was that obviously, when we are creating our testing environment, the devices usually that we are creating and the VRFs are very intuitive. So very often we are saying like service iOS 1 VRF test deploy. Normal thing. But when we move to the testing environment on the customer premises, we realized that, well, devices are not really iOS, but devices are like a XYZ hostname with the VRF like a JPX10. So once they starting inserting the services in the CLI, that was after some time really confusing. What is what? I mean, what is my key right now? If that's a device, if that's a VRF, and if you are looking on the services, it was like a service XYZ JD10. It was really unknown for the person configuring this what they are doing. That's why if you have more entries in your keys and the service, not only in the service itself, but if you have any kind of list that you have multiple keys, it's sometimes worth to actually include the tailf CLI expose key name. It will add you the name of this structure while fulfilling the key of this list, but at the same time, it will be clear for the operator that they are configuring actually this parameter from the flow of the CLI. Tailf hidden, that's something that very often people know. The people that are doing the nasty things, they are using the tailf hidden just to hide something that is temporary there and shouldn't be there. That's not a good practice at all. Very often we are using the tailf hidden to hide from a NORBOMF interfaces some of the packages. Very often the RFS packages. So if we have the stacked services with the CFS, so customer-facing services, and the resource-facing services, we don't really want to expose these resource-facing services towards any end user, any operator. That's why we are using the hidden true in this case to just hide it from the web UI, from the CLI, whatever. But we can also use that kind of structure here as our storage. So if you have any kind of the action that in this case, for example, calculate the LSPs from some external system, you can fulfill that information in your model to later on further reuse it for the service instance creation that will be sitting there in your configuration database. And then we are coming to the container, most specific features. Presence one, very often used, but I think it's a good example to actually show you more in depth how it looks like from the practical perspective. If we have a L3 VPN, we can have a specified routing protocol. Very often we have the BGP, usually, I guess. But we have also the protocols like OSPF, EIGRP, like underlying, or maybe some static routes. But usually we don't have all of them enabled at the same time. So to configure each and every protocol, we are just picking the part of the configuration, and there are mandatory leave elements. And by default, if we leave all of these containers without the presence true, it will be asking us for all of the mandatory parameters from all of these containers. This presence true actually allows us to make that kind of choice that, okay, I'm choosing the container OSPF in this case, and then I'm forced to fulfill the whole mandatory parameters only from this container because I've chosen only that one to use in our service. Tailf CLI drop node name, very often used. Here we are using this mostly when we are hiding some constraints. So one more time, when I was telling about the when statement from the very beginning, that we wanted to have like a container IOSXR to include some of the specific IOSXR parameters and features, if that kind of device we are configuring. We don't want for the operator, obviously, to see this IOSXR in the CLI because, I mean, our goal is to be multi-vendor and to hide this from the operator that we are doing the multi-vendor service. So that's my kind of goal for you, that anytime you see that you can hide some constraints by using the containers and the tailf CLI drop node name, use this. It might be a bit more complicated young data model, but it will be way much more intuitive from the perspective of the operator, and that's actually our end goal always, to do that. That's just another example for the Junos. If we have some Junos specific thing, we can use as well this tailf drop node name. And that might seem unprofessional. I mean, if we have the interface type and the port, and we are leaving port as a string, especially that the Junos rather models it as an interface name. But I'll come back to that example a little bit later, so you'll understand what is missing here and how we can actually do this better. Tailf CLI flattened container, just again to enhance the experience of the operator to speed up the process of configuring the service. Here the goal is that if we fulfill all of the linif elements in this container where it is used, we don't need then to specify the exit in order to go back and enter another container to fulfill another parameters. Small change, but it actually allows you to speed up again and enhance the experience of the user. Add mode, I would say it depends on the preference of the operator with the add mode, if we want to use it or not. It's rather up to you whether you want to fulfill the long snakes in the CLI, or you want to introduce the new mode like a VRF config mode, QS config mode, some routing protocol mode, and then fulfill all of the parameters that are related towards that. If you want to fulfill all of the snakes in the CLI, you can leave it like that. If you want to have that sorted for the specific configuration, like for the VRF config, you can use the CLI add mode to have it more intuitive for the fulfillment. List stuff, obviously, again, very often I'll be referring here to list, but it might be as well a feature for the leaf list. For the entire support matrix, you can visit the developer.cisco.com/NSO documentation, and you will see where else you can use it. For me, here the most important part is that you will understand what is behind that and what are the opportunities. Minimum, maximum elements. That is, again, something very simple. I don't have to really deep dive into that. If we have a list, we are just specifying what should be the limitation for the minimum number of elements or maximum number of elements. But I've seen a couple of times that someone was specifying a list and including the mandatory parameters on that list, and then that person was expecting that, well, if I put the mandatory here, that means that the service instance, while fulfilling this, should prompt me to trigger those mandatory elements. I mean, by default, it will not, because if there are no elements in the list and you haven't put this limitation, this restriction for these minimum elements, it will just skip this mandatory. Just one tip: if you need just a single element to be fulfilled and it has to be really list, then you can include these minimum elements, maximum elements as a single one in order to limit to just single one value. Flagy syntax, again, some beautification in order to insert our leaf list elements in a single line, the multiple elements, and don't use the square brackets before and after, speeding up the stuff. Compact syntax, that's another one more related towards the personal preference. So let's say here we have the VRF configuration, again, that we are specifying the VRF name, a local AS number that we are picking, and each and every parameter that we'll have under this container for the VRF or anything else, normally we'll have in each and every line copied with the name of this container. So it's like a VRF config, and each and every parameter. That's quite long. If we want to have it just per that container that we are using, all of these parameters listed like a long snake again, we can use this compact syntax to achieve that. Sequence commands. Oh, I like that one very much, because I've seen multiple times people coming to modeling the service, and they are leaving this option for the operator to fulfill which parameter he wants to actually configure right now. Sometimes there are situations that you shouldn't leave that, because if we are talking about, let's say, the configuration of the interface, we have IP and a mask. Are you going to bother the operator specifying first mask or IP? No, it should be enforced. First IP, then mask. I mean, that's the obvious flow that we are following. Same is like a source and destination on the link. Why we cannot just speed it up for the operator to say source and then destination, not like give me the choice whether first destination or the source. That's a natural flow that we should follow, because the network engineers are used to the CLIs that they are coming from, and we should make them life easier. That's why it's really good practice to use it in that way. First, tell the CLI sequence commands under the list, and the operator will be fulfilling in the order of given elements all of these inputs without bothering for 10 parameters. Incomplete comment. Now the Backstreet Boys should appear here with a DJ to sing the incomplete, but unfortunately I don't have that for you. Although I have here the flag that we are using to tell the operators that after using this comment, we should still enforce for fulfillment of the next parameter. because using this, we are not able to hit the CR in order to go to another mode. We are using this in the previous one, sequence comments and the incomplete comment all together, in order to make sure that all of the parameters from the container is fulfilled in the order until the end. And NSO actions very quickly, because there is not much to talk about in terms of the young data modeling, and I'm just touching this today. Actions are executing the methods in the NSO. And from the young perspective, we are always specifying here the name of this action. We are attaching the action point, so where we will actually execute this. And we have the input and the output. Input, so what we are giving to our function, to our logic to process. Output, what we are expecting to achieve as a result. Maybe some success message like that was good. Again, this is just an action point, so as I was saying, we need to somehow tie this with our callback that we have in the Python language, where we'll just provide our logic further. We can also have like a standalone executable program or script, not really necessarily developed inside of the service package. We can have the confirm text in order to make sure that this action is really executing what it has to execute. So with actions, there is a kind of a trap that once we hit the enter, we are done. So I've seen multiple times people developing actions, clicking enter, and then doing, oops, that shouldn't happen. And so my recommendation actually from many of the developments is that it's actually good to include in the model your logic for implementing the commit in the action in order to have the same behavior as for the service, to trigger the fast map to see what is the difference that is being produced, and still to make sure that you are really know what you are doing, not to hit the commit and then do uh-oh. So if you here in these inputs next to, for example, those devices, model this as a container commit with the presence true, and then the options for the dry run, like enum, CLI, native, and the XML, and then process that inside of your Python logic by using the flags. So if input is commit dot dry run dot out format native, then use the process with your logic and use the commit flag in the end with the native, then parse the result towards your output to see the diff that will trigger in your fast map. Don't shoot blindly your actions if you think that it might really disturb your network. But here we are coming to I think the last one that I wanted to show you is the completion action point. So that's the moment if you are entirely hopeless with your XPath notations, with your references, with your hints in the CLI, you can use something that is called completion action point. And here we are in the runtime touching the Python code, Python action, actually, in order to provide us in the CLI the hints for something that is a bit more complex. We are using this CLI completion action point with the name of our action. This is custom thing that it's not necessarily your action. Don't copy paste it like that. And then in Python, we are creating a new action in the code that will just be registered with that one. And we develop our logic, whatever you want to do in order to actually get a list with the results of the hints that you want to present to the end user. Then we bypass this to the NCSDP API in Python, and specifically the method of the action reply completion, that list with the results. And at the runtime, we'll be able then to see the results inside of our CLI. And here I'm getting back to the example with the L3VPN service interface port. So that's a case when we have a list of the interfaces where we have the composite key of the interface type and the port. The issue is if we have the composite key of the interface type and the port in our service, then if we even model our interface type, we are not able to reference anyhow to the port, to any existing ports in our model. Because that's a key. I mean, we are not able to bypass this value that we inserted as a key and see what are the existing, let's say, gigabit Ethernet ports while specifying this key here. So the solution actually for that, in order to not leave it like a type string to be able to insert anything that customer, that operator that actually want, we are using this action reply completion callback. Just a short description from that. So as I was saying, from the NCSDP, we are importing the action reply completion method. And inside of our action that is registered in Python, we are using the CP completion callback that is being provided. We are obviously opening our MAPI transaction as in each and every action we do in order to execute something on the CDB. We are defining the result list that we are aiming to fulfill with the data that we want to present as a hint towards our operator. In this case, we are analyzing the key path, so the CLIs that were introduced till that moment of hitting this tab for the port when this callback is actually going to be triggered. And we are just taking some kind of one-liners to grab the device name and the interface type that we fulfilled so far. So this device and interface type that we fulfilled so far. Now we are at the port time, and at the port time, we are getting all of the existing root devices, device for this device name, config, Cisco SXR, interface type, ID related elements. And then in the loop, we are fulfilling our result list with, that is defined by the API. I mean, that's the NSO core work. That's a tuple with the 3 elements. And the middle one is our hint that we are looking for in the CLI. So in a loop, we just retrieved all of the gigabit Ethernet interfaces for this given device, and we bypassed this to action reply completion that immediately popped up in the CLI. That's kind of a Python feature that is around the young. So it's really good to know such one if you need to use it. And going to the summary right now, I was telling about this 3M rule that I'm always following in my developments. So as I said, there are many different ways that you can accomplish the same goal, but following the 3M rule, be modular always. So if you are developing a big service, let's say L3VPN, split it up for some smaller services, even based on the stack services, smaller RFS packages like a VRF, QoS, BGP, whatever you have else there. And if you don't think about using the LSA architecture, you might use the groupings. Don't forget about those. So if you've ever used something more than once in your model, don't do that. Just put it into the grouping and reuse across. I've seen already like 1,000 something models that customers were developing on themselves. And my general recommendation always is try to really split it logically. So you can decouple the modules even in the single YANK. Even if you don't want to create a separate packages, just don't maintain the entire L3VPN in the one YANK file. And reuse those modules across the packages. Maybe you need to reuse the VRF in something else than your L3VPN service. that may come with some time, actually. You might not that at this point. Be modular. There are tons of tools. There's like a Younger option. We have the Pyang. We have now the Developer Studio that I'm really excited about that will come just right after this session. Try to have a look into your young data models from that kind of perspective to understand if that structure is really following what should exist there. If you are repeating some structures, put it into grouping, try to really reuse. Here is also how I'm starting always my developments. So I'm not jumping immediately to the young development and writing all of these structures. I'm always trying to see what kind of variables I need to fulfill, what kind of parameters, and I'm opening my notepad and I'm just fulfilling it like that, my design of the model. Then only I'm jumping towards the development of the real entire young. Second one, be meticulous. Be really meticulous about all of your inputs. Don't really copy-paste from the network element drivers, as that's not the good practice, because we are creating a service abstraction here. But if you have no clue about what is a type and what are the limitations towards the value that we need to fulfill in order to create our service, you can work with your network engineer, or you can also check in the net in order to not allow for the value that is not possible to go through for the physical device. And that's really, really important. Declare your modules version, so you'll thank yourself later on for that. If you are making some changes, just keep the revision, keep this information handy to not get lost of what has been done and what is the current state of that. And the third point, last point, be mindful. I mean, that's connected with all of those previous things that I was just showing. Keep it simple for the operator. You might add some additional container in your model, but if that will make the entire experience of the operator way much better by the CLI or the northbound interface, such as WebUI, do it. Use all of those learned tricks. Obviously, we had just 1 hour for that, so not that enough to learn all of the tricks, but you can learn that later on. Containers with the CLI drop not name for the vendor-specific config or any kind of the conditionals hidden in the container. Sequence comments to speed up the flow of the operator. CLI completion action point for this complex leaf ref at the runtime. Again, preventing the mistakes in the service inputs to not pass any kind of the unwanted inputs. And as a key message, the automation is as good as the data model. So if you fail at this step when you are developing your data models, you can have a very beautiful code written later on, but that might already fail. You need to really make sure that at this point everything works perfectly to go ahead with the next steps. And obviously, as a part of all of these DevNet sessions, I strongly encourage you to visit the developer.cisco.com/NSO to continue your learning with the learning labs. No matter if you are introductory level, advanced level, there are tons of the useful labs that I've already checked, and they're constantly updated. We are at the developer track, but if you want to check from the operator of the net DevOps engineer track, feel free to do that. Also, great documents that are there. I think that's it. Thank you very much for your attention. That was full hour. If you have any questions, feel free to reach out to me. I think we are at the top of the hour, so I'm not sure if the time allows.
Yeah, we do have time for some questions, but we have nothing in Slido at the moment. So if you don't want to ask your question using the mic, please put it into Slido.
Or grab me for a coffee.
Or was this fully exhaustive explanation of the tips and tricks around Yang modeling? Maybe there was nothing left to ask about, right? So.
Well, I hope so. Actually, I have one last question towards you all, because I was talking with a couple of people already, and that kind of explanation with showing you in the CLI way what is happening without using this flag, for example, and with using this flag is kind of helpful. I think we are missing that kind of explanation at the developer.cisco.com. So if you just can raise hands telling that, comparing this view from the CLI perspective, how does it look like, would be beneficial in adding in the documentation. Okay, quite some of you. So I think we can take that topic further.
All right, then I have a final question for you, Bartosz. So what are your favorite tools for editing and inspecting Yang models and personal preference of tools?
Personal preference actually is a perfect one towards the next topic that we'll have, so the developer studio. I'm quite excited about this session. I want to actually see more of that. I just started working around that, and to be honest, it's not the quite long experience with this tool, but I have to be honest that it's really impressive of what I've seen, what are the possibilities around the XPath, around the Yang data modeling, how to also speed up the process. So I would say that definitely that will be my number one. But still, the second one I would say is a Notepad and your experience that you are just designing the data models for the service.
Look, we actually have some questions now on the screen here. Are service device model the same as modular? It's a question.
Modular or? Or modules? Modules. Yeah, I mean, that's a Yang data model. If you have a look from the top of this document, you will see that it's a module. So each and every kind of a feature is described as a module. If you have a look on the open source data models, every feature, AAA, I don't know, CDP, BGP is a separate module with the separate namespace. So in terms of our network element drivers, we have also specified the modules at the top. So, well, I would assume that if you're thinking about the Yang data models, they are described by the Yang modules that we are writing.
So we have some more questions. Where are all tail-off extensions to Yang documented with examples like what you just presented?
Developer.cisco.com/NSO. There you can find all of these tail-off features. There are some examples by presenting this in the model, in the whole structure. There is some description. There are some websites as well, the old tail-off documents, I think that those features were described. But if you compare what was done at that time and what is currently in the developer.cisco.com/NSO for these extensions, and that's exactly like that named, tail-off extensions, then you'll be quite impressed because it's really comprehensively described there. We are just missing this CLI to show you what is before and after, and I think then we'll be perfectly sorted in terms of the documentation of those things.
And maybe we do a quick answer on the final questions on about how to create a diagram from Yang.
Diagram.
I guess that's a visual representation.
Yeah, I mean,
right?
the visual representation. I mean, I haven't worked on things like that. I mean, that's kind of like a node graph, but I don't have any handy recommendation for you in order to give it like that. Is there anyone from the NSO team or else that can recommend?
John, I think, has some input here.
Yeah. Yeah, I mean that will generate that version. Yeah, but no, they're specific.
All right, thank you very much.
Thank you too.